Hey everybody, what you're going to see here is a clip to a bigger video on solving systems using substitution. You'll end up going through 4 systems that will give you a little bit of extra practice as to some look-fors, some things to try, and some situations that might arise dealing with some pretty straightforward solutions, some integer solutions, as well as some fraction solutions. So I hope that this clip really helps you out. Good luck. Okay, I think we're at the point now where we should be trying to solve this system on our own. So what I want you to do is I want you to go through and try to produce a perfect solution for the system you see in C. That is, you're going to have all of the gold and the blue if you're keeping up with my colors, but we want a perfect solution to C. So let's give it a shot on our own. I want you to pause the video now. Okay, we're back. Let's get a little confirmation. So I can label those as equation 1 and equation 2. I'm going to scan my equations. Do I have a coefficient of 1? And I do in equation 2. I'm going to isolate and get my y all by itself. So I'm going to take equation 2, and I am now going to rearrange it. I've got the same issue, so I'm going to think about that y coming over to the other side. That means that the y will be all by itself if I get rid of that 11, which means I have to subtract 11. Now that my y is all by itself, I can sub that equation, which was equation 2, into the other equation, which is equation 1. Okay, if you made a mistake isolating for your variable in equation 2, then I want you to pause the video now that it's corrected and finish it off. If we get to a point where you see a solution, then what I want you to do, make the correction in your solution and then pause the video and try it on your own. Okay, we always want to be trying these on our own. So now what we're going to do is we're going to take equation 1. That's what it says sub 2 into 1. So I'm going to take equation 1 and I'm going to start copying it out. And now that I get my y, I can replace my y with what it's equal to. And there is the rest of equation 1. Okay, there is my equation with one variable. And now we're hoping that this is pretty automatic. We can expand in our 6. Now I can isolate my variable. To get rid of a minus 66, I have to add 66. So I'm going to take 66 and then minus 15 from it. So that is going to end up being 51. And now I need to divide out that 17. And man, do I really hope that that goes evenly. And it does. There's my 3. Okay, I'm wrapping my solution around. I've now solved for x. So I can sub that x value back into one of my originals, and equation 2 definitely has smaller numbers. Now, it doesn't matter which equation you sub it back into because it is the same for both. So I am hoping that you subbed it back into 2. But just in case we have a little bit where we think in our mind, even the smallest amount, that it matters, I'm going to sub it back into 1. I don't want you to. I hope you subbed it into 2, but we'll just get a little confirmation as we work our way through. If I replace my x with 3, then 5 times 3 is 15. To get rid of that plus 15, I need to minus 15. And to get rid of my times by 6, I need to divide by 6. And so I'm hoping that we get a little confirmation that when you subbed your x equals 3 back into equation 2, you got a y value of negative 5, and you can see that we got the same thing regardless of which equation we subbed into. Okay, I'm hoping that that one gives you a good check, and I'm hoping that we're feeling a lot more confident with solving by substitution. Okay, let's take a peek at another one. So let's take a look at the system that I gave you on the screen. And I'm hoping it's not throwing you a curveball for the fact that we got rid of our x and our y, and now we seem to have equations with a's and b's. Hopefully that's not an issue. What I'd like you to do, go through, solve that system on your own. We'll see if we match up in the end. Okay, give it a shot. Pause the video now. Okay, we're back. So if you are not labeling both of those equations as equations 1 and 2 because you think, oh, look, I know what I'm doing, so I don't need to write that, I think you're making a big mistake. That costs you no time, and it's really going to keep your solution organized. So there's my equation 1 and 2. I'm hoping that we see that the a in equation 1 has a coefficient of 1. So I'm going to want to take that equation and isolate for a. Now, I just have a habit of always writing the other variable term next and the constant on at the end. But obviously, had you written it as 2 minus 3b, to save having to deal with a leading term that's negative, totally fine. I happen to get into a habit the other way, but that's just me. So let's say we took equation 1. We can now sub equation 1 into equation 2. And now as I scan my way across, I've solved for a in equation 1. So as soon as I see my a in equation 2, I can replace it with what it's equal to. I have the rest of equation 2. And now I solved my problem in essence. I have one equation with just one variable. So we can expand our brackets. We can isolate our variable. So let's collect our variable term into 1. Let's get rid of our constants. So right now on the left side of that equal sign, I have 4 subtract 3, which is a 1. If I get rid of a plus 1, then I get a minus 1. And I got that to work out to a nice, neat value of b equals 1. So I'm going to now sub b equals 1 back into one of my originals, and I'm going to sub it back into 1 because 1 just looks smaller. It's got a coefficient of 1 on my a. So I can now replace my b with 1. 3 times 1 is 3. And I can solve for a. Okay, at the very end, what we have to confirm, when we state our solution, our solutions are always in alphabetical order. So make sure that you put your A solution first and your B solution second. Okay, hopefully that matches up. We're doing great. We'll try another one. Here we go. Okay, so you can see the system we have sitting in front of us. I think this is our last straightforward check. So I want you to work your way through E and hopefully we match up in the end. Okay, pause the video now. Okay, we're back. So we've labeled equation 1 and equation 2. I'm hoping that you can see in equation 2 that our n has a coefficient of 1, so we're going to try to get that n all by itself, which means I have to get rid of a plus 3m. Now that my n is all by itself, I'm going to take equation 2 and sub it back into the other one, to equation 1. Okay, I can start copying out equation 1, and wherever I see my n, I can replace it with what it's equal to. There's my equation in one variable. I can expand my brackets. This case being really conscious of my signs. I can clean up my variables into one term. I can then get rid of my constant and collect that. And now we notice, I'm going to get something ugly. I'm going to get an m value of negative 19/13. Now, the reason I wanted to walk through something like E, I really want to make sure that I don't put this idea in your head that when we solve a system, we always get nice, neat numbers, like integers. And I'm going to bet that after doing 4 problems together, I had maybe built up that instinct for a bunch of you that you thought when you got an m value of negative 19/13, you made a mistake, that you had goofed up somehow. And I'm hoping we recognize we didn't goof up. It's just that sometimes points of intersection, the variable values that make both equations true, aren't nice and neat. Okay, that doesn't change anything that we deal with. You've just solved for m, for one of the values. Now we need to take that m value of negative 19/13, and we're going to sub it back into one of my originals, and I take a look, and equation 2 is probably going to be easier. So wherever I see my variable m in equation 2, I can replace it with what it's equal to. Okay, all this means is I've got a little bit more work to do when I go through to solve that equation. I need to multiply negative 19/13 by 3. I got to triple it, which means I triple my top. I triple the number of things. So 3 times 19 is 3 times 10 is 30, and 3 times 9 is 27. There's a negative 57/13. And I'm going to go ahead and I'm going to get my n all by itself by getting rid of that minus 57/13. Now, some people are going to want to write this line in, and I'm okay with that. But I hope that we can see we're going to take 8 and we need to add to it some 13ths. We're going to need a common denominator. And so I'm hoping that many of you would say, well, if I know I'm going to need a common denominator, I'm just going to get that right side to be in 13ths, which means I'm going to have to multiply my 8 by 13 to change that fraction. Well, 8 times 10 is 80, and 8 times 3 is 24, so that is a negative 104 plus 57. Now, very quickly, you can see that my 104 over 13 is 8, and then my 57 over 13 is my 57/13, that I've got my correct value. Now all I need to do is simplify the top, and I'm running out of room a little bit, so I'm going to shrink that down. I'm taking negative 104 and adding 57. So that's going to be a 47 that's negative on my 13ths. I can do a quick little check. I would add 47 to 57 to get to 104. So I check out and I'm good. Okay, what's the only problem? I haven't stated my solution. So therefore, and I know I have to list it in alphabetical order, so the m value has to come before the n value. And there we go. Okay, I'm hoping that you knocked E out of the park, but I'm going to bet that I had a number of people stop when you solve for m because you thought you made a mistake because you got something ugly. And I'm hoping that with this one problem, I've now taken away that feeling. No, it is totally fine to get something ugly. In fact, ugly solutions are going to pop up probably more often than neat solutions. So trust yourself in the process. Rearrange your equation. You're always on the hunt if you have a variable with a coefficient of 1. Rearrange, sub it into the other one, solve, sub it back into the original, find your solution. Okay, great job if you got down to that solution, and way to trust your instincts. Okay, I want to try another system that's got something a little different in it. Here we go. Okay, so I want you to take a look at the system that I gave you in F. And you're going to notice there's something different about this system than all of the rest. If you went through to try to solve that system, everybody should be calling equation 1 and equation 2. But now we're scanning every part of that system, looking at all the coefficients, and we're searching for a coefficient of 1. And now we notice we don't have a coefficient of 1. That means that at some point when we go to isolate for one of those variables, we're going to have to divide out a coefficient, which means we may have fractions. Now, what I want to do really quickly is I want to take both of those equations and I want to go through and isolate for each variable. I'm going to do it fast. So I would assume that we are okay to isolate each variable. So if I took equation 1 and I wanted to get the x all by itself, now I'm going to have to divide everything by 3. Notice you get something pretty ugly. If I wanted to take equation 1 and get the y all by itself, notice you get something pretty ugly. If I took equation 2 and I got the x all by itself, hey, I don't get something quite as ugly. If I took equation 2 and wanted to get the y all by itself, I get something just as ugly. So I want you to take a look at all 4 versions of me isolating for either individual variable in either equation. And you'll notice one of them is maybe a little bit easier to work with. Take a look at what happens if I went and isolated in equation 2 for x. You'll notice I don't have 2 fractions, and that might be easier to work with. Now, I want to take a look back up at our original system and maybe see how we could identify that at the very beginning. Take a look at equation 2 and notice I'm going to have to divide 2 out of the 6, or I'm going to have to divide 6 out of the 2. And I notice that 2 does divide into 6 evenly. And so maybe that's what drives my decision. That I may look at all 3 terms within my system and just see, hey, if I go to divide out my coefficient, does it divide evenly anywhere? And if it does, that might make my life easier. So I'm going to erase all of that stuff that I just put down, because all of that was just to help me maybe make my life easier afterwards. With some practice, we may be able to scan, 3, 5, and 4. If I divide by any of those values, the 3 or the 5, it doesn't go evenly into anything in equation 1. But if I divide a 6 into a 5, I notice that at least my 6 does divide by 2 evenly. And so I would be motivated to take equation 2 and try to get the x all by itself. That allows me to say, okay, 2x equals negative 6y plus 5. And so now when I divide out, I actually get at least one integer. So something to help you out when you go through to solve systems where you don't have coefficients of 1. It doesn't mean that because I don't have a coefficient of 1, oh, shoot, well, I can't use substitution to solve. No. The method of substitution is universal. It just might mean that we might end up getting some ugly values or expressions when we try to use it. Okay, I think this is your test now. If you could go through and finish off solving that system, then I think you're pretty solid with your algebra with substitution. So I want you to pause the video and try to give it a shot. Okay, pause the video now. Okay, we're back. So everybody should be taking equation 2 and subbing it back into equation 1. Now, because it's fractions, or there's a lot of fractions, I'm anticipating that this is going to get uglier in our process. But I'm taking equation 1, and wherever I see my x, I'm subbing in what it's equal to. That gave me an equation with y's. I can expand my brackets. 3 times 5 halves is a 15 halves. Now I can collect my variables. I can put together my constants. Well, right now, I'm going to have 15 halves plus 4. So that is a 15 halves plus 8 halves, which is a 23 halves. You may like to write that line in, or maybe you want to get rid of the 23 halves. In either case, we're going to come up with this equation. And now, to divide out a 14 means I'm going to multiply that denominator by 14, and I get a y value of 23/28. Ooh, ugly. So now we've got to finish it off, and I'm just going to shrink that down a little bit because I need to sub y equals 23/28 back into one of my originals. Now I take a look at my originals and I'm like, ugh, I don't know which one of those would help. However, you might notice something. I want to show you what's going to happen if I sub this into equation 2. I go through and I start copying out equation 2, and wherever I see my y, I know I need to replace it with 23/28. Now, we may be tempted to multiply that 6 times 23/28 by multiplying the 6 times the 23. But you may notice that my 6 and my 28 both have a common factor of 2. And so if I do a little cross-reducing, 6 divided by 2 is 3, 28 divided by 2 is 14. I can actually deal with some smaller values since I subbed it into 2. So if you look back at my original system, when I had 23/28 and I was trying to decide, do I sub it into equation 1, I can see I'm going to have to multiply by 5. Well, there's no common factors between 5 and 28. So that one told me, don't do that. But if I take a look at equation 2, 6 and 28 do have common factors. So that one became the one that I wanted to choose. Now when I go through to simplify that equation, I'm going to get smaller values. I'm going to multiply 3 times 23. That's a 69/14. And so I'm going to end up dealing with smaller numbers. Okay, I'm going to slide this over a little bit. Make a little more room. Now I can go through. Now, I'm going to solve this equation maybe a little different. Previously, I've solved all of them by just getting rid of your constant and getting a common denominator. Now, we should all be comfortable to do with that. That's just fractions. It's just common denominators. But some of us may prefer to eliminate our fractions. And so if we look down at the bottom, our last equation line, we may choose to get rid of our divide by 14 by multiplying everything by 14. And so maybe that's going to make your life a little bit easier because now you don't have to get a common denominator, let's say. 5 times 14 is 5 times 10 is 50, and 5 times 4 is 20. And so when we go through to solve that equation, that may make our life a little easier. Okay, only thing left to do, state our solution. My x comes before my y, and there we go. So I'm hoping that when we work our way through that, we can notice, hey, our original system didn't have a coefficient of 1 on any of my variables. That didn't really matter. We just still pick one of the equations, we rearrange it, get one of the variables all by itself and sub it in. Worst case is we might end up getting some uglier values, but we're okay to work with fractions. Okay, great job. Now I want to change gears a little bit.